Okay. Okay, so if some of y'all are like, no idea what she just said. Okay, so the way I got that was I just multiplied 3.1 times 2, divided by 2 to get 3.1 moles of SO3 from my SO2. So then right underneath it, I'm going to now do my other equation. Start with your given of 2.7 moles of O2. And I want you to go all the way through it. And I want y'all to do it, try to do this one on your own. So we're doing, again, your starting point is 2.7 moles of O2. Okay, this is how y'all can tell me you're done. If you kind of like swipe your mouse across your screen, you can see where there's reactions. Let's see. When you're done, give me a thumbs up. Let me see how it does it. Oh, okay. Hey. Do y'all have that? Yeah, it should
under
be.
the chat.
What?
It's under the more button. Like
Oh,
we have different reactions too.
because like mine at the bottom of my screen, it has like chat, pause, stop recording, breakout rooms, and then it has reactions on this whole like little strip. Y'all's isn't easy to access.
Yeah, it is. It's over to the right where like all
Yeah.
our names are, and like you just
Okay. Yeah. So just like click on that and give me a thumbs up when you're done. Nobody's done yet? Is this what y'all got? Yay, nay?
I got it.
Okay.
I think some of us are putting like a little like check mark 3.
Yes. Okay. So just remember, just think about the cereal and the milk if you get confused. So the limiting factor would have been the milk, which is what you have less of. So here's our milk. The 3.1 is the limiting factor. And so we have an excess of O2. So our limiting and then our excess. All right. I'm going to skip down to, it says number 7 on y'all's and any of the other ones. Okay. Let's balance this equation first.
Through what you're doing to balance that.
Oh, sure. Okay, well, first, of course, I'm listing out my my elements. So I have hydrogen, sodium, oxygen, and hydrogen, sulfur, oxygen, and sodium. And I'm gonna do the same on the other side. But remember, I'm gonna list them in the same exact order. So hydrogen, sulfur, oxygen, and sodium. And then how many hydrogen do I have on my reactant side? Katie? Or do you want me just to talk you through it?
Yeah. I didn't know if you heard me too.
Yeah, I heard you. No, there's
Okay.
3.
Oh yeah, 3. I didn't see that other one. My bad.
Okay. All right, so 3. And then there's
1, 5, 1.
okay. And then hydrogen on this side.
2, 1, 5, 2.
Okay, now when we're looking at this and trying to figure out where to start, what do we not start with?
The H2O.
Okay, well, we don't start with hydrogen and oxygen. So leave hydrogen and oxygen to the end. Unless hydrogen and oxygen are the only 2 things that are in it, then you leave those to the end. So then we look for the next thing that's not balanced, and we see that sodium's not balanced. Okay, so let's look at our sodium, and okay, we see that there's 2 on this side and 1 on this side. So let's balance the sodium, because that's the other thing that's not balanced. Okay, so to balance the sodium, I would come over here and I would put a 2 in front of this. So 2 times 1 is 2. And then I have 2 times 1 is 2, plus 4 more is 6. And then 2 times 1 is 2, plus 2 more is 4. Are you with me so far on that?
Yes.
Okay. All right, so now I know I have 4 hydrogen and 6 oxygen. So now I'm going to go over here and balance out my hydrogen. So to do that, I'm going to do, sorry, I know you have it in front of you too, but I just put what? A 2 in front of my hydrogen, right? Because there's 4 over here and 2 over here.
Yes.
Okay. So 2 times 2 is 4. and then 2 times 1 is 2, plus 4 more is,
Oh, 2.
no, 2
What?
times
2,
1 is 2,
2,
plus
yeah.
4 more is
6.
4, 4, 1, 1, 6, 6, 2, 2. And when you follow the rules and don't start with hydrogen and oxygen, they can be that simple. Because some of you are probably sitting there and started somewhere else and are like knee deep in not this, which is fine. I mean, because I know that we can work our way into rabbit holes with these things. But you see how when we followed the rules and didn't start with hydrogen and oxygen, how quick it went. All right, so it's 1, 2, 1, 2. These are moles. We have 25 moles, or excuse me, I'm sorry, 4.5 grams of sulfuric acid. Oh, good, this is a grams to grams one. Okay, so 4.5 grams of sulfuric acid reacts with 10 grams of NaOH. And our question is how many grams of Na2SO4? So the two things that are gonna be our starting points are, this is one starting point, this is another starting point. Our ending points on both is this one. So we're gonna be doing grams to grams. This is our grams to grams is gonna always be a 4-step process. It's gonna go from the given to periodic table to moles to periodic table. So let's start it. Given 4.5 grams of H2SO4. All right. Now, if I just said to you, hang on one second, I'm getting a glare from one of my other. All right, if we have grams of H2SO4, which we know goes down here, okay, and I just said to you that the process goes given, and I'll write it underneath it, so y'all can also put this in your notes if you need to. Given, and then periodic table. So we have grams H2SO4. Some of you already have your calculators out doing it. So we know that if I said that's periodic table, our grams of H2SO4, this is where it has to come from the periodic table. So you should have your periodic table out and looking up, adding up these numbers. All right, what'd y'all get when you added it up?
I got 98.086 grams of H2SO4.
Okay, so 98.07.
Yeah, that too.
Okay. All right, so we have grams, and we know it's from the periodic table. We have to do grams to what?
Moles
Yep.
of H2SO4.
Yeah. So it's 1 mole of H2SO4. Following our typical rules, moles of H2SO4 goes down here. Now here's where we have our stoichiometric ratio of our moles to moles, where everything changes from where we go from our H2SO4 to our Na2SO4. And the way that we do this, the whole reason why we have to have a balanced equation is so we have the mole to mole ratio from the reactants to the products. So that's why it has to come from the balance equation, and why we have to use the moles from the balance equation. So our moles of H2SO4, as you see from our balance equation, there is 1 mole of H2SO4. And as I just told you, you're going to be putting moles of Na2SO4. And from our balance equation, there is 1. Following this, moles of Na2SO4. So periodic table, mole, mole, periodic table. So we have periodic table moles. We know that's going to be 1. And if we're trying to figure out grams, we're going to have to put our periodic table grams of Na2SO4. And of course, that has to come from our mass from the periodic table. So we'll have to add that up. So grams of Na2SO4, getting that from the periodic table. All right, what'd y'all get?
I got 142.05 grams.
Okay. I didn't put on the 0.05, but I will. All right, so now go through and multiply all the way across, get that number, then multiply all the way across the bottom, get that number, which shouldn't be that hard. So, and then you divide the top divided by the bottom. So basically it's going to be 4.5 times 142.05 divided by 98.07. So go ahead and do that and then write that to the side. So you should have gotten 6.5 grams of Na2SO4 from H2SO4. I'll look over here and see by check marks if you got it correct, or thumbs up or whatever. Okay. All right, so I'm gonna have y'all do the next one on your own, and that'll be the test to see how you do, but I think y'all will do great. And then we'll move on to percent comp. So the next one is gonna start off, I'm not gonna erase this whole thing, but I need to give myself some room here. The next one, our given, starts off with 10 grams of NaOH. I'll go ahead and show you that. And y'all go ahead and try to do this one on your own.
Um, 17.7 grams.
Okay. Yeah, I got 17.8, but yeah, that's it. So 17.7, 17.8, that's basically the same thing. So this is what it should have looked like. That's the answer that you should have gotten if you didn't get that. So clear where you have your thumbs up and whatever, everybody clear those off. And then, so I want to see if you got those correct. So just put a check mark if you got it correct. Sorry.
Miss Blaschka, why wouldn't you just round it up to 18 grams? Because the original one was like 10. Because I know we had talked about like earlier the scientific notation or whatever. I don't even remember the sig figs or whatever. Like the first one is 10 grams of NaOH. So why wouldn't the answer just be 18 to match like the numbers? Does that make any sense? I feel like I'm not.
Yeah, then it should have been 17. The original number was
10 grams, wasn't it? So like when you round everything to two places, at least at the end.
10.0. So I should have
Oh.
rounded it to 17.8.
Okay.
Okay,
Thank
so
you.
you're welcome. Thank you. I should have noticed that. Okay, so like most of you got it right. Okay, let's see. For those of you who got it wrong, what went wrong? Where did it go wrong? Ricardo, where did it go wrong?
I just multiplied it and came with you. That's all it was.
Oh, okay, but you have it set up right?
Yeah.
Oh, perfect. That makes me feel good. Because then if you just multiplied it wrong, that's just a calculating error. It's the setting up part that's the difficult part. Well, then don't make a silly mistake.
Yeah. All right.
Okay. All right. Well, perfect. Okay. Let's see. All right. Awesome. Okay. Well, are y'all ready to move on to percent comp or percent yield? I should say. Yes. Woo. All right. I'm gonna take that as a yes. Nobody said absolutely not. All right. So percent yield. See, my worksheets say different numbers. I think it was 374. I don't know. Top of it looks like this. Y'all, percent yield is so easy. So the actual formula here's the formula. I should say actual formula. The formula is this: actual divided by calculated times 100. That is the formula. And so if you have this worksheet in front of you, you can read it along. But I will write on here basically what it says. All right, it says determine the percent yield for a reaction if a student collects 27.8 grams of product and the calculated amount of the product is 30.0 grams. So where it says actual versus collected, or calculated, excuse me, actual is what comes out of the experiment. So what did you get out of the experiment? Calculated is what comes from the balance equation. So if what was calculated from the balance equation, if it's like in grams of something, and then actual is what you actually got when you did the experiment. So the student collected 27.8 grams. So the student had 27.8 grams, and the calculated was 30.0 grams. So figure out what the percent yield of that product was, going by the equation that I gave you.
Can you show the equation again?
Sure.
No, the number one, like the other one.
Oh, I'm sorry.
Thank you. I got it. Thank you.
Okay, you're welcome.
I got 92.7% yield.
That's correct. Jenna, and where it says determine the calculated theoretical amount of the product O2 for the unbalanced reaction given 25 grams of the reactant KClO3. All right, I'm going to give y'all the unbalanced reaction first, and then I'm going to type the question into the comments for you guys while you are balancing it. For those of you who don't have the worksheet in front of you.
Do you still want us to turn these worksheets in after we do it?
Till the 31st. So
Yeah.
like, are we not supposed to be doing anything right now?
You're basically hang on, let me type this question real quick and then I'll answer that question, okay?
Okay.
But that was supposed to be a capital O. I knew I couldn't for some reason see what I wrote. Everything's getting squished. You finished already?
Mm-hmm.
You loaded everything?
Yeah, Sean.
Anyways. So that was supposed to be a capital O. All right, so to answer, I think that was Katie talking. Right now, what you should be doing is basically making sure that you're caught up on everything. And I can tell y'all 100% that not everybody is. I put in a lot of zeros, but I'm not going back in and having to regrade everything is a big, huge pain. So y'all make sure you're getting your stuff in. Then there is a study guide up for unit 6. So I would go in and start trying to do as much of that as you can without your notes. And I was going to put that up today, but I didn't want to start anything new since spring break is next week, and I don't want y'all to have to do anything over spring break. I was going to give y'all basically the whole week to just like not have to worry about having to do all this hard stuff at home, because I know this is hard, and I know this is hard on y'all, because this is a lot.
Wait, I have a question. How come when I get on Power School, I can't see the grades? I only see the Unit 5 test grade.
You can't see where I have like the checks and the squares and stuff?
I can't either.
Serious?
Yeah, I haven't seen I any just
grade.
my one grade.
You what? Can nobody see their grades on there?
I can't either.
It's just a one grade.
What? Okay.
My geometry class is working, but not this one.
That makes me so irritated because I put in, hold on.
I can only, through the list, I only see like the check marks above.
That's what
everything.
That's what you should see. I put in, because I was telling my mom this the other day, I put in 1,350 grades the other day between my 3 classes. And so, okay, well, I'm glad somebody can see them. That just probably means your Power School isn't refreshing for some reason.
I see it now. I'm looking on my phone right now.
Oh, okay.
Yeah, I just refreshed mine and it shows collected on all of them through the FET worksheet.
Yeah.
I see it.
Okay. Whew. I was about to say, because that was a lot of grades I put in. Like I said, think about all those over my 3 classes. It was so much. Because I just kept waiting and waiting for them to tell us what to do. But didn't tell us. Anyways, all right, did y'all get 223? Yes? Yeah, okay. You should have gotten 223 for this. Did anybody not get 223? Oh, crazies. All right, so this is a different type of question because it's asking us to figure out, first of all, we have to figure out how much oxygen we have or that we're going to be able to get. Then we have to figure out the percent yield. So how do we go about doing this problem? What do we have to do first? How do we figure out how much O2 is going to be produced?
You have to go through the mole tunnel with the grams from the KClO3 to the O2, or the grams O2.
That's correct. We have to do a grams to grams problem. So that's what I want y'all to do. Our starting point is 25 grams of the KClO3, and your ending point is going to be grams of O2. So I want y'all to do that grams to grams problem. So again, you're going to start with 25 grams, and I wrote the problem in the comments box. 25 grams of KCl. Just look in the comments. It's a lot easier to read the text than my handwriting. If y'all will clear your comments off and then re-put them back up there whenever you're done. Thank you. Good. Those that aren't done yet, just having problems or. Then I added a second part to the question down at the bottom. Or if you look at the comments. Okay, Sage, what did you get for the grams of oxygen?
Sorry, I'm not finished yet. I forgot to take off the check mark.
Oh, okay, no problem.
That's my fault.
No, no worries. Wait, a lot of them just disappeared. I think, I don't think there's a lot of people that were done with that. Are we having trouble with setting it up, you guys, or? All right, Emily, what did you get for the grams of oxygen?
I got 9.79 grams.
Yep, that's what I got as well. And if you're not,
I was a little confused on like I got the answer, but it just didn't seem right because for my mole tunnel, I did 25 grams of KClO3, and then the wait, I think I did the molar mass for KCl3 under that. KClO3, sorry.
yeah, that's right.
And then above it, I put 2 mole KClO3.
Yeah, that's not right. How did you end up getting
Yeah.
the right answer?
I don't know. Because you're supposed to put 1 mole above that because that equals
Right.
1 mole. So I don't really know how I got that.
Well, at least you caught your issue.
Oh, I see what I did. I did I think I did that times 2 and then put the 2. I don't know why.
You probably put the moles from the balance equation up there for some reason,
Yeah. Yeah, I think I did that.
but that goes in the next slot.
Okay. Yeah,
Wait.
I just multiplied the molar mass by 2 and then put 2 mole. I don't know why I did that.
Oh, okay. That's why it turned out then. Okay. All right. And then before I show everybody how the whole thing looks, I asked y'all to also find the percent yield for the reaction if the oxygen is 7.5 grams. And again, if you're not done with this, just keep going because I'm going to go over it. Let's see. Hallie, what did you get for this?
I got 76.5%.
Okay. Yeah, and I got like 76.6, but basically the same thing.
Yeah.
Okay. So let's go through how to set up this problem to get the first part. You start off with your given, and then from the periodic table are grams to moles. So the grams of the molar mass of the compound to 1 mole, because it's to 1 mole of the compound. And we're bringing down our moles of KClO3. This is where we have our moles to moles from our balanced equation. Moles of O2 come here, periodic table. Moles of O2. Remember, if you didn't get it right, you probably put 16 up here. That's been the biggest issue is O2. O2 is 16 times 2, so it's 32. Multiply all the way across, divide by everything multiplied across the bottom, and then you get 9.79 grams. And then the bottom one, so this is the calculated amount. From the balance equation, this would be the calculated amount. And then I asked you if what somebody got from their experiment was 7.5. You do actual 7.5 divided by calculated 9.79 equals, or times 100 equals 76.6. Which let me put those numbers there real quick. Just, I know most of y'all have that, but so it was 7.5 divided by 9.79. Any questions on this particular problem?
I do.
Okay. Go ahead.
So you put 1 mole KClO3, but the coefficient's 2, so why did you put 1 and not 2?
Right here,
Yeah.
because this is from the periodic table. This is my standard ratio from the periodic table. If I have from the molar mass 122.6 grams, then that always is going to equal 1 mole. Because
Alright.
remember, if potassium is 39.1, if 1 mole of potassium equals 39.1 grams, and that's 1 mole, well, all I'm doing is adding up all of these different molar masses, making it 1 compound. So that means that I have 6.02 times 10 to the 23rd compounds of this particular compound. So that equals 1 mole. That's how many basically amounts of compounds I have. Because think about it, if you had individual elements of each of these, you'd have 6.02 times 10 to the 23rd individuals of each element. But we're putting them all together and making a compound. So now once they're put all together and making a compound, they're all as 1. So now you have 6.02 times 10 to the 23rd of the compound.
Alright.
Right?
Yeah.
So that equals 1 mole.
Okay.
Hopefully that helps with understanding the mole in relationship to compounds and individual elements, because I know that can be a little bit confusing. And then over here, when we do mole to mole, that's where you're doing the conversion of going from whatever your given is to whatever you're trying to figure out within the balanced equation, because you have basically what goes in and what comes out, and law of conservation of mass, nothing being created nor destroyed. Here is the ratio. 2 moles of KClO3 to 3 moles of O2. And that's our ratio. And so we know by putting this ratio in that this is the only way that it could work. And that's why we have to have the balanced equation. And that's why I said in our last unit that y'all have to know how to balance equations.